At Krypton Analytics would like to present our latest innovation called Punkt, a tool to help customers booking flights on aggregating websites such as Kayak and Expedia make much more informed decisions. This presentation will develop on our analysis of flight delays in 4 different phases. We will first identify the problem faced by passengers due to flight delays, then elaborate on the analytical approach that we used, followed by the outcome of our research. Flight delays are an inconvenience to passengers. Besides the mental fatigue, passengers in the United States are not entitled to compensation when a delay occurs. A delayed flight can be even more costly to a passenger who is on a multi-plane trip. According to an organization called Airlines for America, the cost of delay to a passenger flying is over $46 for a minute of delay. Having access to the information about the risk of delays will help him convert that cost to a saving and add another dimension to the customer preferences during the flight booking journey. By leveraging our in-house data mining techniques, we decided to use the flight data from the Bureau of Transport Statistics with details of more than 50,000 flights that took off for or from Pittsburgh during the year 2014 and 15. A statistically representative sample. The data gave us information about flights such as arrival times, airline name, carrier type, date, type of airline, origin, destination, and whether a flight was canceled or diverted. The decision of whether a flight will be delayed or not also depended on whether the features would be present at the time of booking the flight. The 3-step strategy that we followed to build Punkt was to first explore, in other words, identify relationships between features of a flight and test our commonly held beliefs about flight delays. The next step was to filter the data. This not only made our analysis simple, but also avoids chances of mispredictions by amputating anomalous behavior of delay-causing situations. Using the filtered dataset, we built a predictive model. This means, given features of a flight such as date, time, time of departure, and destination, Punkt would classify the flight as delayed or on time. Moreover, when we segmented our data on the basis of airline carriers, we found out that the top 5 delay defaulters were Envoy Air, American Airlines, AirTran Airways, United Air, and Delta Airlines, averaging delays of close to 60 minutes. This means that on an average, if a passenger books an American airline flight and if it was delayed, it would cost the passenger $2,760, counting the costs of flights and the money value of time. Even though exploring the data helped us verify our initial intuitions about the business problem, the value of our forecasting model is to a large extent influenced by the structural relationships between the factors that affect a delay. A key observation was made. If a flight is delayed, it's very unlikely that it was because of the make of the flight, the delay in security checks, the time at which the flight took off, or whether the flight was cancelled or diverted. To build our delay forecasting model, Punkt, we used a very well-known data mining technique called random forests. The power of random forest algorithm is realized in its ability to weigh the importance of interrelationship between the features that we selected in our previous phase. The features that were fed into the model and the flight is classified as a delay or non-delay. For example, if we consider only delayed flights from our dataset and segment those flights by takeoff time, destination, origin, and airline company, our algorithm would select maybe those flights that were Delta Airways and took off at 12:50 a.m., or those that were Delta Airways, took off at 12:50 a.m. and were destined for Chicago, and it would determine which combinations of feature would make a better decision. Considering and weighing the importance of such permutations of segments of data, our model becomes extremely robust to mispredictions and makes our model a good fit for any given flight. In the interest of the passenger, we would be successful in avoiding choosing a much more expensive flight if Punkt mispredicts a flight as a delay when it's actually not. Our vision for implementation of Punkt is based on the age-old economics concept of signaling. Signaling in the flight booking industry is key in manipulating decisions of flight bookers. Most of the signaling features or decision metrics of aggregating websites are price of the flight, the departure and the arrival times of the flight, the brand name of the airline, and the duration. Each of these fuel the decision of booking a flight. With our plugin, the website would allow the passenger to specify an additional amount the passenger is willing to spend for a less riskier flight, $46 in this example. And together, Punkt, the money value of risk, and the decision metrics of other aggregated flights listed on the page would rate each flight by their risk of being delayed. This data-driven decision would save customers time, which eventually translates into money.